Hey, hi everyone, welcome back to class. So today we're going to do the next part of forces, and today we're going to talk about air resistance. So before we talk about air resistance, we'd like to talk about the previous lesson. We actually talked about friction. If we can remember, friction has to do with a force moving in one direction and friction being a different force opposing it, right? So in Newton's first law, if we remember, an object that is at rest will always be at rest. An object that is in motion will always be in motion until a force acts on it. And so last week's lesson, we talked about the force being friction. So other than friction, there is another force that will actually act on an object to slow it down. So today we're going to talk about air resistance. All right, let's go. So before we go into air resistance, I'm sure a lot of you are wondering, how in the world is air able to stop certain things? Or how is there friction in air? So the first thing I'd like you to take a look at is a simulation of what air is. In this simulation, we can see the air is actually moving much faster than we think, because the simulation actually has slowed down the molecules to 417 billion times its actual speed. So if air is not moving, it actually really is, and at really high speeds. And so do you imagine walking through all of these air molecules, having them bombard or hit you as you go? This is where friction comes from, or we will call it air resistance. If you can't visualize what the simulation was like, now take a look at this picture. Just imagine air molecules, air everywhere is encapsulated in balloons. We put all the air in the world in balloons. And so wherever you walk, wherever you go, you keep bumping into these balloons. So imagine the air molecules are like these balloons in this picture that we see. If you keep bumping into them enough, it will slow you down. So this is what air actually is like. And so now let's go into the lesson on air resistance. Okay, so for that part of the video, we talked about what air is. So air actually is matter. It has its own mass, it has its own weight. But because it's so light, we don't actually feel it, right? So another analogy or another example I could think of is, imagine yourself in water, and imagine water is now air, right? So there is always a lot of drag, there's a lot of resistance. Well, the resistance that we get in water is called water resistance, and the resistance that we get outside in the open is called air resistance. Now let's imagine this particular situation. You're a paratrooper and you just jumped out of a plane. You're free falling from the sky. Did you know that there are two forces acting on you when you fall? What do you think these two forces are? So the first force is gravity, and the second force is your own weight. So what does air resistance have to do with this? If you can tell, you are falling through air molecules, very much like in the video before, as we showed you. Air molecules everywhere, and they will actually bombard you and they will cause friction as you move through it. So as the paratrooper is going through air, he's meeting up with air resistance. So what is air resistance? In physics, air resistance is a force that is caused by air or air molecules. The force acts in the opposite direction to an object moving through the air. So if you're going to fall downwards, the air resistance is going to move upwards. So it's an opposite force that will slow you down if you're falling through air. If you're driving really quickly, it will slow you down. So as you can see from the picture, gravity and your own weight is actually pulling you down towards the earth. However, because of the air that you're in, the air resistance is the thing that's holding you back, slowing down your speed, causing friction in the environment which you are in. Okay, just to summarize what we just learned. Everything has a mass, everything has a weight, and gravity is a force that pulls this weight down. And so air resistance is actually the force that's actually slowing down or lessening the force that gravity has on us. All right, so we're going to move on to the next part to talk about things that will affect air resistance. Okay, so what can we do to increase air resistance or lessen air resistance? It depends on what you want to do. For example, if you're falling out of a plane on a parachute, do you want to fall down fast or not? Or if you are a pilot and you have a plane, do you want air resistance to slow you down? So it depends on what your needs are. And today we're going to discuss two factors that will affect your air resistance. The first one would be surface area, the amount of space something takes up. And the second part is streamlining. Streamlining is actually using design or using certain characteristics, physical characteristics, to reduce the amount of air resistance. So when it comes to surface area, the larger the surface area, the greater the air resistance, because you have a larger amount of space to catch air or allow air to work on the surface or on you. So that's why parachutes are way bigger than a person. It's pretty obvious, right? So the last bit of the video actually shows a Japanese man trying to overcome the forces of air or moving air, which is wind. So they hooked him up with a air machine and they're blowing wind towards him. And take a look at how he's actually trying to, I don't know, beat the machine. All right, guys, let's go. I don't know. Japanese shows are really cool. Funny, I guess. They do really, really strange things. Don't follow, please. Okay, suy nghĩ cho khi nói, suy nghĩ cho khi làm nhé. Okay? Okay, and so for the next part of the video, I'm just going to show you a clip from a science show that I watch all the time. Alright, and I just cut it up. But note that this is actually an American video. And so instead of using the word air resistance, they would use the word drag. D-R-A-G. That means to pull something along. So I put out the word use air resistance instead of the word drag, but when they verbally speak, they'll still use the word drag. And you know, I think what I would like you to pay attention to the most is actually the animation, because they have really good animations on showing you how air resistance works against a body. Okay, let's go.
Have you ever played under a parachute at school? You and your friends hold onto the edge, flip it up towards the sky, and then slip inside and watch it slowly float down on top of you. Or maybe you've seen a skydiver jump out of an airplane. After he jumps, he falls through the air, and then he opens up his parachute. The parachute slows the skydiver down, so he falls gently towards the ground and can make a safe landing. But have you ever thought about how parachutes work? Well, in the end, parachutes work because of air. That's right, the stuff that's all around us. We're breathing it right now. And air, like everything else you can feel or that takes up space, is made of matter. That's what scientists call just stuff. Everything is made of matter. The parachute, the air, the ocean, you, me, everything. And since air is made up of matter, when you walk through the air, you're actually pushing matter out of the way with every move you make. But here's the thing. That matter is pushing back on you, too. You probably don't feel it when you're just walking around, but when you start running, you might feel it a little bit. And when you start to go even faster, like when you're speeding around on your bike, whoa, that feeling is the air pushing against you. And this force has a name. It's called drag. Drag is the force of the air pushing back on you, or on anything, when it moves. And the faster something is moving, the more drag it feels. So you don't really feel the force of the air as you walk around. But have you ever held your hand outside the window of a moving car? That's some serious drag. You can feel the air pushing against your hand, and it can be hard to even keep it still. But have you noticed that it's easier to hold your hand flat like this than it is to hold your hand so your thumb's pointing up? Like this? Why do you think that might be? It's because when you hold your hand straight up like this, more air is bumping into your hand. That means more drag. But when you put your hand flat like this, only a small part of your hand is pushing the air out of the way. There's less of your hand for the air to run up against, which means less drag. So your hand can glide through the air more smoothly. So what if you're a skydiver and you're jumping out of an airplane? How do you slow yourself down so you can land safely? You'd want to do something that would make more air bump into you. And that's how a parachute helps. It makes more space for the air to run into, so it creates more drag. There's so much drag on the parachute, so much air pushing against it, that it slows down your fall, so you can land safely. Now, a lot of other things experience drag too. When a boat moves through the ocean, the water that pushes back against it is also making drag. And cars and trucks experience drag when they're driving down a highway. A little car feels less drag than a big truck because it has less space for the air to push against it. So drag is the force that you feel when you're moving through something, like the air, and that something pushes back. It may slow you down, but it's what makes lots of things from skydiving to playtime with parachutes possible. Thanks for joining us.
Okay, and so the last part of our lesson, it's actually a very interesting thing. Did you know that all objects fall at the same rate? Whether it's a sheet of paper, or a cup of coffee, or a pair of glasses, everything will fall to the ground at the same time, like this. Okay, but because of air resistance and how it actually acts on each body, acts on each thing, it causes things to slow down or speed up, right? So for example, if I drop these two things at the same height, they should fall at the same rate. But because of air resistance, which one do you think will fall first? Of course the heavier thing, right? Okay, but we're gonna watch an experiment where there is no air resistance. So for this video, it's done by the BBC, and what they've done is that they've put a bowling ball and feathers into a vacuum. And in a vacuum, there are no air molecules, and we're just gonna see what happens when we remove air resistance to the equation. Objects will all fall at the same time? Will they? Will they not? Will it be affected by its weight? Let's take a look.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out the 30 tons of air in this chamber until there are about 2 grams left. And it's kind of got an eccentric construction, which is part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems, and that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding and part an external pressure vessel. So this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest. Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So in order to see the true nature of gravity, we have to remove the air. It takes 3 hours to pump out the 800,000 cubic feet of air from the chamber.
Okay, we dropped 2 millitorr in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCB 30-1, pressure set point at 240 psi. We are go for drop.
10, 9, 8, 7, 6, 5, 4. Cameras on. 2, 1. Release.
Exactly. They came down exactly the same. Wow.
Look.
Watch right there. Look at how they hit right there.
Exactly.
You're back on the side.
Exactly the same.
Feathers don't move, nothing. Look at that.
That's just brilliant. Isaac Newton would say that the ball and the feather fall because there's a force pulling them down, gravity. But Einstein imagined the scene very differently. The happiest thought of his life was this. The reason the bowling ball and the feather fall together is because they're not falling. They're standing still. There is no force acting on them at all. He reasoned that if you couldn't see the background, there'd be no way of knowing that the ball and the feathers were being accelerated towards the Earth. So he concluded they weren't.
That's crazy, right? So, isn't that very interesting? There are so many things in this world that's out there for us to explore and understand. So, I understand that sometimes, we come to class, it's like, it's physics, it's science, it's chemistry, it's hard. It is hard, but once you actually get to understand what they really are, it's really, really cool. Right, guys? So, hopefully you guys enjoyed your lesson. Please remember to do your summary sheets, and then there will be some Quizlets as well. So I'll see you next time for next lesson, and hopefully we'll get to see you soon in class, alright? Okay, bye guys.